Hello everybody, I'm the Optocoupler Product Manager for Broadcom Isolation Product Division. I'm very glad to be invited by Nexperia today to talk about driving GaN with Broadcom Optocouplers. This is today's agenda. I'll begin with a brief introduction of Broadcom's Isolation Products Division and an overview of our Optocoupler portfolio. Next, I will showcase the new 10 ampere gate drive autocouplers suitable for driving wide bandgap power devices. And in particular, using a half-bridge evaluation board, we'll discuss the details of the gate drive design, test, and measurement of Nexperia new CC-Pack GaN. This slide shows the critical milestone of Broadcom Optocoupler beginning from HP in 1970 to Agilent and finally the merger with Broadcom. Today, we are celebrating more than 50 years of providing safe isolation and especially driving power devices like IGBT and power MOSFET. Moving forward, we are committed to invest in R&D and continue to deliver exciting isolation products for driving wide bandgap silicon carbide and gallium nitride devices for industrial and automotive applications. Broadcom has a wide portfolio of isolation products from digital to gate drivers to voltage and current sense. We are your one-stop shop to meet your isolation needs. In today's presentation, I'll focus on the new 10 ampere gate drive autocouplers and how they can be used to drive wide bandgap power devices like GaN. Broadcom will be releasing a series of 10 ampere gate drive autocouplers this year. They come in basic single-channel ACFL 3161 and dual-channel ACFJ 3262, or the smart version, the ACPL 355JC with short-circuit protection. We have been working with leading SiC and GaN power devices with these 10 amp gate drivers. Today, we'll focus on half-bridge evaluation board using Nexperia GaN in CC-Pack with the dual-channel 10 ampere ACFJ 3262 gate driver. The half-bridge evaluation board features ACFJ 3262 and Nexperia's GaN 039-650 MBB FET. The half-bridge evaluation board enables the basic study of the switching characteristics and efficiency by means of configuring for synchronous rectification in either bulk or pulse mode. The high voltage input and output operates up to 400 volt DC with a current limiting of the inductor at 15 ampere to 16 ampere depending on the operating conditions. Dual channel gate drive autocoupler ACFJ 3262 can deliver 10 ampere peak current to drive the GaN FET directly or multiple GaN FETs in parallel. It has wide supply range of 10 to 20 volt meant for FET with gate voltage normally lower than IGBT or silicon carbide of 15 volt. It has fast switching speed and high noise immunity above 100 kV per microsecond for high frequency operation and DVDT switching. We are sampling the ACFJ 32622 now, and the release is expected in the fourth quarter this year. Nexperia GaN FET requires 0 to 12 volt gate voltage for optimum switching. The evaluation board caters for two isolated Murata 15 to 12 volt DC-DC converters and the 12 volt linear regulators for this purpose. Bootstrap supply option is also available, and it's able to reduce the supply capacitance and inductance, which can create resonance and loads the switching node. The ACFJ 3262 drive the GaN FET directly using a 15 ohm gate resistor. Ferrite bits are fitted in series with the gate of the GaN FET and should be located as close as possible to the gate pin. The ferrite bit damps the resonance circuit made up of the gate source loop inductance and the GaN FET input capacitance, thus providing fast switching stability. At the ACFJ 3262 input, the output LED use a split resistor network of 120 ohm at the anode and cathode. This is to balance the input impedance of the LEDs to achieve the high DVDT immunity of 100 kilovolt per microsecond. Lastly, 14-volt TVS are used to clamp and protect the gate of the GaN FET and the gate drive output. The TVS diode, however, has to be selected carefully to prevent any adverse effect on the switching performance. Double pulse tests are conducted with the GaN half-bridge evaluation board at a bus voltage of 500 volt and the drain current at different steps up to 60 amp as shown as the oscilloscope capture on the left of the screen. The switching performance or the switching on and on waveforms are clean and with a DVDT recorded at more than 50 kilovolt per microsecond without any false triggering from the gate driver. Bulk conversion is also performed from 400 volt to 230 volt at 100 kHz switching frequency. The conversion is able to achieve close to 99% efficiency using Nexperia GaN and Broadcom gate driver. Before I end my presentation, please scan the QR code on or visit Broadcom Reference Design website for more details of the evaluation board. In the link, there will be email contact, and if you will need the design files like schematic, layout, or even a request a board for testing. Once again, I would like to thank Nexperia for this opportunity and you for listening.